Hey there, boys and girls. All week long, we've learned about quadrilaterals. So tonight, we're going to review them. Let's get started. First question asks, which type of quadrilateral can have exactly one pair of parallel sides? So the clue word here is exactly one pair, all right? So let's think about the definition of each of these. For a rectangle, think a rectangle has four sides, two opposite sides that are parallel, two pairs of parallel sides, and four right angles. So it doesn't have exactly one pair of parallel sides. A rhombus, think about what the definition of a rhombus is. Four equal sides, right? A square, four equal sides and four 90-degree angles. And finally, a trapezoid can have, what is that? You're right, at least one pair of parallel sides. So the correct answer is D, trapezoid. Question number 2 says, WXYZ is a parallelogram that's not drawn to scale. It says, using what you know about parallelograms, give the measurements of sides X to Y and Y to Z. So let's think about where X to Y is. Let's look up here. X to Y is here. Well, this looks like it's either parallelogram, probably not a rhombus because it doesn't look like it has equal sides. So I'm going to look at the opposite side that's parallel. Down here it says the side W to Z is 6 centimeters. So I'm going to guess that side X, Y is 6 centimeters because it should be opposite, equal, and parallel. Now it says find the measure of Y to Z. Well, Y to Z is right here, isn't it? But there's no measurement. So I'm going to look on the opposite side, and it says from X to W is 3 centimeters. So my guess is Y to Z is also 3 centimeters because they, again, should be equal and opposite. Now let's look at problem B. It says WXY, so the angle, W to X to Y. So it's here, W to X to Y. This angle right here, so it's an obtuse angle, is 113 degrees. Use what you know about angles in a parallelogram to find the measure of the other angles. Well, I know if this angle is 113 degrees, that was a bad degree mark, wasn't it? Let's do that a little bit smaller. 113 degrees, then I know the diagonal angle right here is also 113 degrees. So I'm going to say this one's 113, this one's 113. So now think about what you know about a quadrilateral. All four angles, what's the magic number that we learned in class this week? Always equal 360, right? So let's take 360 and subtract 113 and 113. Well, 113 times 2 gets me 226, doesn't it? So now let's subtract. 6 minus 0 can't do it, so I got to borrow. 10 minus 6 is 4, 5 minus 2 is 3, and 3 minus 2 is 1. So now I have 134 to split up between my last two angles. So I'm going to split that into 2. 2 goes into 13 6 times, because 6 times 2 is 12. Subtract and get 1. 2 goes into 14 7 times, because 7 times 2 is 14. So I know the last two angles right here is 67 and 67. So now let's fill in the blanks. So now we're looking for angle X to Y to Z. So X is here to Y to Z is how much degrees? 67 degrees. That's right. Now we'll do from Y to Z to W. So from Y to Z to W is 113 degrees. Nice job. And the last one, from Z to W to X. From Z to W to X, that's also 67 degrees. Awesome. Problem number 3 says Jack measured some of the problem segments in problem 2. He found that W to Y is 4 centimeters and M to Z is 3 centimeters. They want you to give the lengths of the following segments. So I'm going to erase some of my work here so you guys can see this again. A little bit easier. All right, so now it says from W to Y is 4 centimeters. So that means the entire diagonal is 4 centimeters, right? So if we split that into two parts, we can say from W to M is half of that, 2 centimeters, right? So we're going to say from W to M is 2 centimeters, and M to Y is also 2 centimeters. Now, it says from M to Z is 3 centimeters. M to Z is 3 centimeters, so M to Z is here. So that's 3 centimeters. So think if we were looking on the opposite side, that would also be 3 centimeters. So we know from X to M is 3 centimeters. Now if we look all the way down the diagonal, X to Z, we see this side is 3, this side is 3, so together they make 6 centimeters. All right, question number 4 says, parallelograms always belong to which category of shape? So think a parallelogram is a shape that has opposite sides that have the same length and they're parallel. So this side is parallel to this side and this side is parallel to this side. So do we know that all parallelograms are always squares? Nope. Are all parallelograms always rectangles? Nope. Are all parallelograms always rhombuses? Nope. But are all parallelograms always quadrilaterals? You got it. They sure are. They always are a quadrilateral. So the correct answer is D. Last 2 questions. It says a rhombus has a perimeter of 217 centimeters. What is the length of each side of the rhombus? Well, I know perimeter means side plus side plus side plus side. So all of those sides added together is 217 centimeters. So with that being said, let's think about what we know about a rhombus. A rhombus has 4 equal sides, doesn't it? So all the sides are the same length. So how would we be able to find out one side of each of the rhombus sides? If you said divide, you're correct. We're going to take 217 and divide by 4. So 4 doesn't go into 2, but it does go into 21 5 times, because 5 times 4 is 20, subtracting it 1. 1 is less than 4, so we're going to bring down the 7. 4 goes into 17 how many times? 4 times, because 4 times 4 is 16. 17 minus 16 is 1. So we're going to make this into a fraction rather than keep going as a decimal. So 54 and 1/4 centimeters is going to be each side of my rhombus, and that's the correct answer. All right, boys and girls, let's see if you can do the last problem on your own. The directions say to match the definition of the geometry vocabulary on the right to the word that describes it on the left. Write the letter on the line that describes that definition. So I'll get you started with the first one. It says a quadrilateral with opposite sides that are parallel. Well, I know, looking on the left-hand side, a parallelogram could have opposite sides parallel, so I'm going to hold on to that one. A trapezoid doesn't always have opposite sides parallel. A rectangle could also have opposite sides parallel, so I'm going to hold on to that. A rhombus could also have opposite sides parallel, but a kite does not. So I know for the first, it definitely can be either A, C, or D. So I'm going to keep going, and I'm going to read the rest to see if I can make a better decision. The next one says a quadrilateral with at least one pair of parallel sides. So I know that's talking about the only one that has at least one or only one, and that's B, trapezoid. And I'll cross this one off. See if you can go ahead and find the best definition for each of these that matches best. All right, boys and girls, thank you very much, and I will see you next time.